I was telling like it was not being recorded. Okay, fine. Okay. So what I was telling was that it has input features are here, then output features are here, then there is hidden layers. So you don't have to design each and every neuron, each and every input. So you just have to use nn.linear, and if you define the parameters, so it will automatically take the fully connected layers. Any doubts on this?
Sir, I didn't understand that hidden layer part yet.
Hidden layer part is nothing but your activation functions. So perceptron, I would have told you, right? So what is perceptron? Okay, what is neural network? Keenest, you have the basic idea what is neural network is?
Not exactly.
Okay, so can you just tell me like where we'll use neural network or something like that? You have the basic idea. Last class I told you like where we use neural network.
Is it in like training the models?
So that is like after like what we do, like what's the application of neural network? So what's your
Okay.
application of ChatGPT? What's your application of Dolly 3? Like what's your application of other things where you use AI, right? So what is
Yes,
that
sir.
core application? No, I'm just asking you, what is that core application? Why do we use that one?
Uh, I don't know, sir.
Why do you use ChatGPT for? Why do you use image generation for?
So to get an output, like we give a prompt and we get an output according to what we
So,
described.
okay. So is it just like giving prompt and getting output? No, right? It is trying to learn from your context. So you just ask question. So can you ask me one question?
Uh, yes, sir. How are you?
Okay. So how are you? Like when you ask that one, what did I understand? I have to whether I have to answer like how I am, like how others are. Like it has to understand something, right? So that A is something not that just give like how are you, fine, not something like that, right? They don't bluntly reply to you in ChatGPT. So it will give you some
Yes.
text. So I'm
Yes,
doing
sir.
good, and how you are. So something like it will give you, right? So it is trying to understand. So this hidden layers is there, right? So that is what will happen. So this hidden layers, it will try to understand the input and try to train on that data. So it's not just like I'm hidden or something like that. I'll just do something or nothing. So main purpose of neural network is that whatever you give, it has to learn from that data and it has to produce the outputs. For example, I'll just give, let's just say there is one boy photo. Okay. So what's the difference between these images?
The lion has mane and the tiger has stripes, black stripes.
Okay, so you're able to find, how are you able to find the difference you told? So tiger has black stripes and lion has hairs.
Yes.
So if I want to like understand it more clearly, can you give more examples, like more characters? So this is also a cat. This is also a cat. It has like fangs, it has eyes, it has nose, it has ears, it has also a fur, right? So how do I differentiate it as lion or tiger?
There are some features that distinguish both of them.
Okay, you just told one example. Like, can you give some more?
The color of it, there's a slight color difference.
Okay. Orange and white is there. Like lion, it's kind of little bit brownish orange. Okay.
Yes.
Then,
From the image here, that's all I can find.
okay. You can find like tiger said, like it's like kind of not as elongated as lion, right? This
Yes,
one, like,
sir.
okay.
But that could vary from angle. Yeah.
That would vary. So that is what neural network is doing, hidden layers. So it is trying to learn the features, like whatever you give from the image, it is trying to learn the features. So that is what the main application of hidden layers is about. Whatever I give, it has to learn some features.
Okay, so each of the hidden networks are like some feature, so it relates to each of them. So if you give an
Now,
input, it relates to each of the feature. Is that
yeah, that is
uh,
what it is doing. For example, one hidden, I'm just giving an example. It doesn't exactly do that one, but I'm giving one example, like how it can happen. But it will happen in convolutional neural networks. But in fully connected layers, I'll just elaborate like how it happens. For example, this hidden layer has some settings, like some mathematical configuration. As you told, what was the first main difference? It was the color, right? So color it will try to distinguish, or it will try to learn from the image. So then it will try to learn uh, the face, what like the what do you call that? Morphism or something is there, the technical word. So it will try to see the face. Then it will try to see the uh, airs and all, right? So this what hidden layers does is like each and every hidden layers has its own parameter to learn or identify. So it will try to find that one and it will try to characterize.
okay? So it passes through each of the parameters and it gives the weights according to it.
Yes, you're absolutely right. So input I'll
Okay.
give, I'll just pass it through all the neural networks. So if it is color is orange, something is there, right? So I'll pass it as like zero point 0.7. So if it is zero point 0.7, like I'll just say it's tiger. If it is zero point 0.3 or something like that, color, so it is lion, something like that. So I'd have set the parameters in order to distinguish correct characters. So for face, if length is about like zero point 0.5, right? So I'll just tell it as tiger. If it is zero point 0.8 or something like that, it is lion. It will try
Okay,
to find
sir.
this value and then it will try to classify accordingly to the classes.
Okay, sir.
So this one like will go in deeper like when we come to image processing and everything. So this one I'm just trying to explain you like what hidden layer does.
Okay, sir.
So it's nothing but like it's trying to calculate some mathematical equations. So there will be something called as I'll just show it to you. Better to explain it that way. So everyone is from biology background, right? So everyone knows this image, what this is.
Yes,
A
sir.
neuron.
Yes,
Yes,
sir.
sir.
Okay, a neuron, right? So what does neuron does? It passes your electrical impulse from one end to the other end, right? From your hand to your brain. Okay. So I'll just ask one question. How do you decide like you got some like you're touching something, right? So how do you feel that it's coming from your which hand? For example, you're touching in left hand or right hand. How do you get to know?
So like the nerves pass that signal to the brain, and then like if it is like the brain recognizes it and sends like message back that that place it is touching.
Okay. So that is what you told is true. Like there's something, I won't go in technical detail. So action and potential and those kind of things are there. So electrical impulse would pass from your end of your neuron to your brain and it will try to recognize. So similar working of your neuron is there, right? Neurons. So this perceptron was designed in earlier stage. This is the basic neural network. So this just has only one hidden layer and only one neuron. We call it as neuron. Single neuron will take, and then we can have multiple inputs assigned to that one. This statement. So this is the neuron. This is the perceptron. For this, there are multiple inputs, and then there is one output which I want to classify. Okay, I'll just like to ask. There are five students who is from class 1, class 2, class 3, and class 4, and class 5. So I want you to let only the class 3 student into this classroom. So how do you do that one? I'll just repeat the question. This is class 1 student. This is class 2 student, class 3 student, class 4 student, and class 5 student. So I want to let class 3 student to this room. How do I do that one?
So we'll make sure to know their classes before letting them.
Okay. So like how do you mention, like how do you set the criteria for that one? So you'll decide someone, that person is class 3, right? How do you decide?
I didn't get the.
For example, like there are three students standing in front of you. I told you have to let only class 3 student. How do you decide? This is just logical. I don't want you
Like
to do
to
technical or nothing like that. Logically, how do you decide whether the student is class 3 student?
Like
so maybe
without
like their
asking,
height or ask them.
Yeah, without asking them, how do you do?
identify them or see their like ID or their height,
One,
their
okay.
personality.
One is that ID. ID card is there, right? So ID card is the criteria. So ID card, you'll see number, some ID number would be there for class 3 students, right? So if they've started in 2022 or something like that, it will start from 2022 something number, and so on. And then what you told, height is there, right? Okay. Height we can't take. It's like everyone varies, right? So we can't take height. So we'll consider only the ID. So this is the parameter which we'll set to identify whether it's class 3 student. So some ID it has to match 2022 or something like that in front. So then we'll check all of their IDs. So first one will come, will show his ID. This is like what we call as activation function. So this parameter which we set is called as activation function in neural network. So this will set the criteria whether I have to allow this output or not to this class. So if his ID is 2024, will it let out? For him, it's 2023, right? 2024, sorry, 2021, 20. 20. So what happens is that this first student will come. There is the guardian over here. You just check his ID. So it doesn't match. So it doesn't let him out. So then this person would come. Will it match now?
No.
Okay. So it doesn't match. It doesn't let him out. So he'll just stay there itself. So then third person.
It matches, so they'll get inside.
Okay, it matches. So he'll send them out. Then this fourth person.
Again, no, sir.
It's not match. Then fifth person also it doesn't match. So it doesn't let. So this third person, like whoever was there, right? So he's class 3 student. So we let him out. So that is how we classify. So this is what classification is about. If some criteria matches in your neural network, you just give it as an output. So that is the basic idea. So in order,
Excuse me, sir.
yeah, Maria,
So this activation function, will it be defined by us, or will it
define.
be
That is the
automatically
criteria.
defined?
Sometimes it will automatically take. If you see this, just a minute. PyTorch, this linear is there, right? Some activation function, like if you give automatically, it will take by default. There are some activation functions. So relu is there, sigmoid is there, and so many are there. By default, it will take some, but we have to define based on the problem statement what we do. So activation functions. It'll come out. Okay. So there are activation functions. So there are so many, like only like handful you can use. So softmax, those kind of things are there. So tanh, signage, those kind of things are there. So using this one, you can set your parameters in order to let the outputs. So if you come over here. So if you can see this activation function is there, right? So weighted something is there. So this step function is nothing but your sigmoid function and those kind of things. So if this function is there, like we'll try to define from torch.neuralnetwork.activation function, and then we'll try to use f dot threshold, f dot tanh or something like that. Then only like we'll make the complete neural network model and we'll get the output. Yeah. So any doubts in this perceptron concept?
No, sir.
Okay. So this is perceptron, right? So you just got to understand one single entity would be there. So neural network would be there. Just name it as NN. So this is the hidden layer. Then what happened is that I'll just copy this one.
Excuse me, sir. One.
Yeah, Maria.
So each perceptron is like one unit of the hidden layer. Is it
Each
like that?
perceptron.
Like
So this is just
like
we call it perceptron because it has only one neural network. So only one hidden layer it has.
so then earlier when we were like defining hidden layer, there were like
I'll just come to
like
that one. I'll just come to that
okay,
point now.
okay.
So this is one, only one is there, hidden layer. So this like we call it as perceptron. So just open. Save. So what we did now was that this one inputs were there, right? Multiple inputs. So this what we take. C control V. This one will keep. So this one will keep. And then so if you remember this class 1, class 2, class 3 and class 4, right? So I want over here fifth class student, one more, 3 and 5. So I got 3 done layers now once again. So what I'll do is like I'll just pass through everything, right? This one. So this one pass through everything. This one also it will pass through everything. Sorry. So if you stack my n number of perceptron, right? So in hidden layers, so that would become your fully connected layers. So this is nothing but your DNN model. So based on the design, we'll call like those names like perceptron we'll call, fully connected layers we call, back propagation, convolutional layer. So the based on that one we'll try to call. So I have shared this image with you, right? Neural networks view, this one. This one I've shared right once. Okay, so input layers, and if you have only one hidden layer or something like that, this is called as perceptron. Feed forward network, so inputs are there, hidden cells are there, then you have an output. So that you call it as feed forward network or fully connected layer or something like that. And this also like this one is called once again feed forward network in large scale. Then RNN model, LSTM models. So based on how you design your neural network, right? So we call them that way. So deep convolutional neural network. Then there are convolutional graph networks, opfield networks, and so many. Like based on your problem statement, what you're trying to solve, we'll design the neural network in order to learn the things. So I'll just share this with you also. You can just go through later. So any doubts on this, like what is this perceptron and other things?
Sir,
Yeah, then
so what is the difference between feed forward and radial basis network?
feed forward and radial basis network. So on there are multiple factors to consider. One is that like how the activation function takes place, or how the hidden layers is totally structured. So they would have given in general terms, but they would have not give the complete details. So if you go through this one, right? So documentation, they would have told function as activation functions. There is nothing more to do. Like if you go through this one, like you'll just try to understand. So how they configure this one, hidden layers and those kind of things. So in general terms, they would have shown the same image. So don't go by the image which they represent. Try to understand like what they're trying to implement and like what is completely happening inside.
Okay, sir.
So just to give you idea like what neural networks and like how they are called, I just showed you this image. So if you see this recurrent neural network, right? So you can see like it is everything is connected, but you can see this loop kind of thing. What happens is that like some training data or some training values would be there, right? So where you can retain in the same hidden layers. So that is what is happening over there. Sorry, in LSTM you can retain. In RNN, like you can get the data back. So in the same hidden layers. So feed forwarded, everything like comes from input and goes out. But here you can just get it back once again. In LSTM, you can store the data there itself in each and every hidden layer. So that is what varies depending on the type of neural network you are designing. So don't get confused, like even if you don't understand the higher concept. So basic idea is that in your neural network, you're designing in such a way that your neural network is trying to learn the parameters or the characters which you're trying to want your neural network to learn, and it will just give you the output. So I have that idea, that's it. So don't worry about thousands of neural networks. There will be one neural network which can do most of the things, and we'll use that one. Just for your understanding, I just explained all these things. It's already 7:45. I didn't complete other layers also. Okay. So convolutional 2D and other things like we'll see in other next class. So activation function was there. Okay, I'll just explain in brief in next class the same thing. Is this fine? So two things I want from your end. So just try to understand like what is told in class, like not go in depth or something like that. I'll teach you in depth in upcoming classes when we're doing the hands-on thing. So just have the general ideas. So this will happen. And then try to practice or try to read some articles or something like that, whatever things I've told you in class. So that would be enough. Is that fine?
Yes, sir.
Okay, fine. Okay, I'll do one thing. I'll just give you key terms which I taught you today. After every class, I'll give you key terms. So technical terms. You can self-study. If you don't understand, just message in the level 4 group there itself, because everyone wants to learn, right? So share it among yourself. Uh, so ask your questions in the level 4 group there itself. I'll just answer there only. Is that fine?
Yes, sir.
Okay, fine. So what I'll do is like, mm, okay, by tomorrow morning, I'll send you those technical terms which and all I have taught you today. Have some self-study. If you don't understand, just message me. I'll just answer to those as well. Thank you, Tanishka. Like you shared, right? So I'll just share the level 4 group. Like you guys join out there. So Youngster is created. Level 4 students. Okay. What about the status of level 3 students who are joining Tanishka in your group?
So, like before, I used to like conduct regular classes for like for everybody. Now I've like divided them so they won't have like single class on the same day. So there are two students who will be who can be promoted to level 3. So I'm teaching them the remaining topics which I told.
Okay. And like if you can send those two students' name, right? Just update in Pioneers group. Like we'll just collect everyone and we'll just add them to level 3. So later we'll start level 3. We just want the list, right? So if you tell they're good enough and they'll work, it's fine.
Okay,
So
sir.
Maria, like your group also do the same. Like who is eligible, like you'll get to know, right? So just list their names and just update. So just promote them. So Keenest also. You can just do that one.
Yes, sir.
Okay. So if you have any doubts, just ask. Like I'll just stay for 5 more minutes, or else we'll wind up this session.
Excuse me, sir.
Yeah, Tanishka. Like I told you, you're not getting that output, right? You can just share.
Yeah, sir. Like, I had another doubt. Can I ask now?
Yeah, sure. You can ask.
So you gave the example of like bird and the aeroplane. Like, when we like give the inputs, like we get the outputs after like get like based on their weights up for the decision making. Like, what if few inputs are like not similar to both of the stuff? Like, what happens in that case?
So in that case, like there will be some equations, like something like mean or something like that, mean value or standard deviation value, like you'd have learnt in mathematical classes, right? So that is where we use. So we are trying to find the closest relation for something it has to match. For example, let's just say some weight, zero point 0.8 is bird, zero point 0.9 is aeroplane or something like that. You get 0.1, right? So you're mentioning in that way, if my understanding is correct.
So can you repeat?
Okay. Some weighted value for aeroplane is zero point 0.8 and bird is zero point 0.9 or something like that. So you're getting zero point 0.1 value. So it's not closest to anyone, right? So you're mentioning that way.
Oh yeah, sir.
Okay. In that case, like which is the nearest value?
Like 8.
0.8, right? So like some mean or something like the standard deviation will try to calculate. So it will try to match for the nearest one and it will try to give not that much prediction value as good or something like that. So it will also that lower number should be lower. For example, it's just saying I'm only like 0.2 percentage, sorry, only 20% I'm positive it's aeroplane and 5% only bird. It will try to give that way.
Okay, sir.
So
So
when
I'll
that
share
much,
my screen then.
you can share. Okay. Can you show that image file?
So, uh, so you mean the image itself?
Yeah, image itself. Can you show that to me?
Yes.
Okay, 9, right? Okay, fine. So go back. Try to run the very first code module. Go above. Run this one. Okay. Second one. Okay. Do one thing. You run that TPU is there, right? GPU or TPU. Like go to resources, setting. Yeah,
So,
runtime. In runtime type. So T4 GPU, right? Okay, it's fine. Okay.
so,
Cancel.
but I think I've like worked with like GPU for like
It's fine.
more hours, but now I cannot use it, I guess.
Okay, so it's running on device CPU. Okay, fine. We'll just run that one with CPU. It doesn't matter.
Yes. So like this is what it says if I use GPU.
Okay, fine. Connect without the GPU. So run the third code and complete. Next one. . Okay, next.
So this took like time before.
Okay, run that one.
Like it took 1 hour or something.
Okay, then what to do is like epochs is there, right? So stop this. Make it to 2 instead of 12 is there, right? First line. Make it only 2. Run that one. Okay, I think so. It will take some time. Just 5, 10 to 15 minutes. Go down. So just see image path. Image is equals to image dot open image path. So just wanted to ask in like see in that prepare tensor for model add batch dimension is there, right?
Yes, sir.
Input image. So what you're trying to do there is like you're just trying to get the random number from test data set once again.
So like should I remove some line here?
That output is equals to best underscore model is there, right?
So
Input
this,
image. That one add my image instead of input underscore image. So my image. So it will try to predict for your image now.
so what about this line?
So at random, it's trying to get IDX random int. So yeah, that is what, like I told you, right? It is trying to get your random image from
So then
test
should
data
I
set.
remove that line as well?
Let it be like you're taking now your my image, right? Output is equals to best model. So it doesn't matter.
Okay, sir.
It will just run and keep the variables. That's it. So you'll not get the same image. But one error you might face is that because the given image is not 24 cross 24, right? So there you might get some issue. I'll just send you one or two lines so where you can convert your image to that pixel size.
So should I add it here or in the previous program?
In that line itself, after you got out before output is equals to best model, right? So before that one, two lines you need to add if you're getting error.
So like here.
Yeah,
Yes.
I'll just send you if you are getting error
Okay,
because
sir.
the input size which you are giving, right? So the uploaded image, it has some pixel value. Let's
Yes.
just say 1280 into 720. So it might not take. I'll just tell you like what to do.
Yes, sir.
Okay. So run this one. See if it is run. Go above. I think so. It's complete. No, it's taking, right?
So like I already did this, like I told you that it was taking time. So I already tried everything and then I got this.
Okay, okay.
So
So
after,
before it, like when you're trying to run that one, right? So it was not able to get that best model. So that's why you're getting that best model error.
oh yeah, sir. Like I got to know that. Like I didn't run the previous codes. That was the issue.
That was the issue. Okay. So just tell me like if you're facing error, I'll just send two more lines where you can correct that one.
Yeah, sir. So then can I like change this to 12 itself and wait for like 1 more hour?
You can make it to 6 or something like that. If you make it 12, right, it will simply run and overtrain the model.
So 6 is fine.
6 is fine because it's small data set and it will just train automatically. Yeah.
Yes, sir.
Okay, sure.
So can
Okay.
I stop sharing?
Now you can stop sharing. Okay. Maria, you have any doubts? Anyone any doubts?
No, sir.
Sir, I have a doubt.
Yeah, tell me.
Sir, you did mention about back propagation, but I didn't quite understand what that was.
Back propagation, like it's like getting your output, like what happens in feed forward network, like which I told in perceptron.
Sir, I didn't get you.
In perceptron, what happens?
Sir, it checks for a specific condition and then it takes the answer.
Okay, let's the answer. Like what direction it is? It's just straightforward direction, right? Input you'll get, will activate and will just send it out.
Yes, sir.
So what back propagation does is like that output it is sending, right? If there is something like you want to train the model once again on some parameter or something like that, you can get that output once again as an input. So that is what back propagation is about. For example, I'll just show it to you.
Mr. Harsha,
Yes, sir.
yeah, how long will it take?
Sir, I'll just end the meeting. I'll just explain it to you later. Yes, sir.
Okay.
Some concepts. Yes.
8 o'clock, we have another meeting.
Sure, sir. I'll just end the meeting, sir.
Thank you.
Thank you, sir.